Let's now have a quick introduction into AWS Athena so that we understand the basics of how this works, and later on we dive a bit deeper into Athena. But here, before we want to demonstrate this, we quickly want to get this very first important overview. So AWS Athena is an interactive query service by AWS. This means that it allows us to query files that are stored in an S3 bucket. So all kinds of files actually. So unstructured data, or like at least semi-structured data like CSV files, but also we can query Avro files, Parquet files. So all types of files that can be processed and that are actually stored in our data catalog. We can query them using SQL. So here we can see we can just run standard SQL on this, what we have set up in our data catalog, so with the database and the tables, and then we can just run SQL queries on this with a very high performance and it is also very scalable actually. So if we have a lot of data, then this automatically scales up for us. So here we have again a serverless infrastructure. This means that we don't have to bother at all with the infrastructure, but it will be just provisioned and managed for us depending on the needs. And then we just pay based on the number of queries and the amount of data that is scanned, so that we don't need to bother with the infrastructure and we just have this simple pay-as-you-go model. So how does this work and how would it look like in a real case scenario? Let's quickly get an overview over this again. We have files in an S3 bucket. So this is where the files are, and now they are just sitting there. And now if we run those crawlers that we've seen before, we can infer the schema and we can set up tables, and also of course we store them in a database in our data catalog in Glue. And then now that we have those tables, we can use them in Athena. So here we can now query this data using SQL. But it doesn't stop here. We can now use Athena as a source in other applications. So we can use, for example, AWS QuickSight. And in here, we can then visualize the data and build reports out of this. But we are again not limited to just QuickSight, but we can use different options as well. So we can use ODBC drivers and connect it to different applications as well. Additionally, we have a few use cases like doing some log analysis. So we can analyze the logs that are stored in an S3 bucket using just Athena with SQL. We can do some quick ad hoc analysis when we have some data that is stored in an S3 bucket, and maybe some data scientists, they just quickly want to get some, do some maybe exploratory data analysis on some files. So this is very quick, very easy, and we can just very interactively run queries on our data. But of course, in general, when we build a data lake architecture based on S3, then we can also use Athena in general to query the data, and later on also build some visualizations, some reports with it. So we can base here this on Athena, so that the files that are stored in our data lake, they are actually queryable and they have a good performance and they are able to be connected to our visualization tools. Additionally, we can also integrate it with streaming data sources such as Amazon Kinesis. And of course, we will have a closer look at Amazon Kinesis in a bit later. But now we have seen this quick overview, and we want to now, of course, quickly also demonstrate this in practice so that we understand why we have actually set up the data catalog, so that we get this connection and this context so that we can make sense of this. So that's what we are doing in the next lecture. Let's now quickly demonstrate this concept of Athena very quickly with what we have set up already. So previously we have set up our database, and in our database we have this table that was created using a crawler where the schema has been automatically inferred from an S3 bucket. So we remember we have this file in this documents folder. So this was now automatically inferred the schema by using the crawler, and therefore we have now this table available in here. But now we want to also make use of this. This is the reason why we have done this. So now we can query this data in this file. And we do this using Athena. So we can do this, for example, if I just navigate back to our main database, customers, I have this option here to view the data. Also, if I'm in the table, I have under actions this option to view the data. And then we are asked if we want to be taken to Athena to preview the data. So of course there will be charges for this. So it is of course also a paid service. So based on the number of queries and the number of read of data that is read, we will have to pay for this. But in our case, it will be very inexpensive actually. So therefore we don't have to worry about this too much. And now we see we are taken here to this interface where we have in Athena the query editor. And of course, we probably see in the beginning this message, no output location provided. An output location is required either through the workgroup result configuration settings or as an API input. So what we can do, actually, this is the message we also see here. Before you run your first query, you need to set up a query result location in S3 so that the query results are actually stored in a bucket. And this is what is needed for Athena. So we can do this just by going here to edit settings. And here we have to set up this query result location. Here we can just choose the bucket. Either we have created a separate bucket before, or we can use the bucket that we have created before here for just this purpose. So we could set up an additional separate bucket, but we will just keep it simple and just select this bucket. So here we select just this bucket. Actually, let's go back and select it from the top level. So I'm just checking this box here. And then I say choose, and this will now create an additional folder where the query results are saved. So under this bucket. We will see this in just a second. So I now just click on save, and then this has been set up. And now we can actually just go back to the editor like this. So we can see this one again. And in here on the left side, we now see basically which data we want to query. Here we can see we choose the customer's database. And then under this database, we have those tables. We can expand this table to see like it would be in a database. So we see these are the columns of the database and the data types of the table, of course. So here we see this table. So it looks like really as if it would be a database. And this is why the name database and tables, because from the Athena perspective, this is how we actually use it. And also now we can run those queries. So we see the database name is customers. And then here we have the table name, and we can limit the results to the first 10 rows. And in this case, we can either run this query like this, or we can also have the preview by just clicking on this table here, these three dots. And I can say preview table. This will open up a new query and run it. So we can see here are the different column names. And then also we have, of course, the data within those column names. And now we can run queries. For example, I can say, what is the average of the age? So if I do something like this, I can run my normal queries. So I say average of, for example, age. And here again, we have this autocomplete, very convenient. So I can just select it from here. And in this case, we don't need to have this limit. And yeah, then I can execute the queries just by hitting Control Enter or just run the query, and we get here the result. Of course, we can now give it an alias, for example, average age, and we can also round the results. So these are all standard things that we can do in a standard SQL way. So if I do it like this, I can see now this is did this in the wrong place. Of course, it has to be after the column. So let me try it again. And then we see here this alias, and also now the result is rounded. So this was just a quick demonstration on how we can use the data in our data catalog by using Athena and query the data that sits in our S3 buckets. Let's now talk about a little bit of an advanced feature, which are the federated queries. So federated queries allow you to query data not only from S3, but also from other data sources. So like this, you can run SQL queries across data that is stored in relational data sources, non-relational data sources, object data sources, and we can even create our own custom data sources. So here a federated query, this is the benefit of this, giving us one interface basically. So we can have in Athena, we just use Athena, and like this we can query data from different sources. And for this, we use so-called federated data sources, which is basically just a piece of code that is translating between the target data source and Athena. So you can think of this connector as an extension to the query engine in Athena, and we can either custom code them or we can also use some pre-built connectors. So we have in this case Amazon CloudWatch logs, Amazon DynamoDB, DocumentDB, RDS, and also other JDBC compliant relational data sources such as MySQL and Postgres. And like this, we can now combine multiple data sources. So for example, if we want to run a quick ad hoc query, so we don't want to build some very complex and very much with a lot of effort, some ETL process, but we just quickly want to do some analysis. Maybe we want to look something up, for example, for a specific customer to review the purchase history, maybe get some additional information about the products that they bought, which could be stored in RDS. And maybe we also want to have the detailed customer profile data. And maybe in DynamoDB, there is the user interaction. So we would have to combine all of those sources, and we could use a federated query to just combine everything in this single interface. And like this, get all of that together. So this is what we can use the federated queries for. Hope it was helpful, and see you in the next lecture. Now let's talk about the cost and also performance. So first of all, about the cost, we only pay for what we are actually using. So only the queries that we run, we are charged for. And this is then based on the amount of data that is scanned by each query. So here we are not charged for failed queries, but only for the queries that are run. And we will be seeing later how we can use this to optimize the cost. So basically, we would just have to reduce the amount of data that is scanned. So keep that in mind when we talk about the performance. Like this, we can also reduce the cost. Additionally, to save some cost, we can also use reserved capacities if we already know in advance how much capacity we need. This is, of course, an additional cost-saving option. Now let's talk about the performance. So this is very important. How can we optimize the performance here? In general, it is good to partition our data. This means that we structure the data into partitions. And then Athena can use something that is called partition pruning, which is basically just eliminating, when the query is executed, those partitions that are not needed for a query. So then this data doesn't even need to be scanned. So we eliminate it right before we do all of the other query processing, so we can focus only on what is relevant. For example, we run a query that is just needs some data on maybe a given region. So then if the data is partitioned into those regions, so we have this S3 directory structure, and the metadata about those partitions is also stored in our Glue data catalog, then we can just, before we go through all of the query, we can, or Athena is just eliminating those regions in this case that are not relevant for us. So maybe we filter this by, we have a query where we filter by a date. So maybe we want to see only the data that is of last month. We apply a filter in our query, and then Athena is using partition pruning. So if the data is partitioned like this, all of the other partitions that are not needed, so that are from a different month, they can be easily eliminated. So they will be pruned. And sometimes This is of course very useful. Usually we use, just in this case, the metadata from Glue, so from our data catalog. And when we, in this case, process the queries, Athena makes a get partition call to the data catalog before the actual pruning. But sometimes this can be affecting the performance if we have a large number of partitions. And to avoid this, we can use partition projection. So with partition projection, we can not only automate the partition management, because then we don't need to manually specify our partitions. It will be done then automatically by Athena, but it can also speed up the query processing for highly partitioned tables. And of course, if we have lots of additional partitions that need to be added, this would also be easy, because here we would have this automation of this partition management. So let's have a look at how this works. Here, this partition projection is eliminating the need to specify the partitions manually in our Glue data catalog or maybe an external Hive metastore. And here it would just basically ignore the metadata of Glue, but it would just build the partitions in Athena itself. So we would just have to configure it in Athena, and we would do this by specifying a range of values and also the projection types for each of the partition columns. For example, let's say we have a date column. We just specify this is our partition column that we want to use for partition projection. And in here, this can be useful, for example, for date columns or for number columns. So sequences where the values are really, they are predictable. So date, for example, or maybe some ID column. And then in this case, when we have lots of additional partitions that would have to be added manually, and also if we have highly partitioned tables where we have lots of partitions, this can really improve the query performance. So here then, during query execution, Athena just uses this information to project the partition values instead of retrieving it from the Glue data catalog. So this would reduce the query execution time and also automates the partition management, because it removes the need to manually create the partitions. So this is something that can be useful for highly partitioned tables. And now also Athena supports the Glue data catalog partition indexes. So like this, we can also optimize the query planning and also reduce the query runtime. So here, when you run a query on a table that again has a large number of partitions, Athena would have to retrieve all of the available partitions from the Glue data catalog. And here we would have to then, or Athena would have to determine which of those partitions would be required, which ones would have to be pruned. And this, if we have lots of partitions, can already be quite time consuming. So when we have a partition index, this can now fetch a subset of the partitions only instead of loading all of the partitions tables. So this can also improve the query planning and reduce the query runtime. And this is something that we can set up in the Glue data catalog. So like this, we can focus only on the partitions that are actually needed, but it is still managed in AWS in our data catalog. Another way of improving the query performance is to enable query result reuse. So first of all, what does this actually do? It is allowing us the reuse of a previous query that has already been returned. And this can improve the performance and reduce the cost, especially for frequently run queries. So you can see in here that you can just enable the reuse of the query results, for example, in the console, and then you would not have to scan through the entire data again, but you can just basically get the stored result, because luckily Athena is also storing the result of the query to S3 as a CSV file. So this is done anyways, and query result reuse is just taking advantage of that fact. So before this feature was available, it was also possible to go into this bucket and query this file manually, but now it is just easier and more convenient to reuse the query result. So whenever we run a query that is matching the query that has already been run, and also the maximum age, so in this case, for example, up to 60 minutes is matching, then it will just reuse the query result that has already been generated. And like this, we don't need to scan through all of the data again. And also, of course, we have a much faster performance. So not only we reduce the cost, but also improve the performance. And this is specifically true for queries where we have a data source that is not changing frequently, because then it makes more sense to just reuse the result that we have already generated. But this is not limited to this. In general, when we have repeated queries, we can enable this and use this feature. And this is specifically also useful for large data sets and also in combination with complex queries. So for example, the result is not very large, but we had to scan to get through this result. We had to scan through a huge amount of data. And in this case, it would be beneficial to use the query result again. And now, lastly, we also have the data format. Basically, here it is good to also compress the data. Like this, we can reduce the size of the data, and this can also improve the query performance, and also it reduces the volume of data that would be scanned. So additionally, this would again save us some cost. And something that is again trying to do the same thing again, reduce the amount of data that would be scanned, is to use a suitable format. So instead of using CSV or maybe JSON, something like this, we should use a columnar format for those analytical purposes. So columnar formats like Parquet or Apache ORC, they allow us again faster retrieval times, because then if the data is stored in columns, it is just much faster, and again the storage is more efficient, so again less data. And the main benefit is that we can only select specific columns without having to scan through all of the other columns. So if it would be stored on a row format like CSV, for example, we would have to scan through all of the rows, but we only want to have maybe one row that we analyze usually. That is something that is more common for analytical purposes. So therefore, this is also something that helps with the performance. All right. So hope this was helpful, and see you in the next lecture. Let's now talk about the Athena workgroups, which are also important in regards to how we organize our different types of queries. Because with the workgroups, we can basically isolate the queries. This means that if we have, for example, different types of teams or different types of use cases, for example, we can have one use case or one type of queries that is just for report generation, maybe in QuickSight, and then maybe we have another use case or another type of workload that would be for ad hoc usage by some maybe data scientists. Then we could create separate work groups for this, or also different applications. And basically we just have different types of settings, and we can also use it to track and control the cost. So like this, we can separate those different types of workloads. And of course, each of those work groups can have then its own configuration. So for example, we can control the query execution settings and also the result location. So this is the location in S3, so an S3 bucket where we store our query results for the queries that we run in this given work group. This can also be specified for this given work group, and also we can control the access to the work group. So of course we can just use the normal resource level IAM permissions or identity based IAM policies. So we can just use basically IAM policies to just control the access to the work groups, and then whoever has access to this work group can use the given work group to execute a query. So we will see in the window just a drop down where we can select a given work group to execute a given query. And also we can, of course, as we have said, control the cost and also the type of the engine that is used. So here the default is, of course, Athena SQL, which is just used usually, but we can also set up a Apache Spark enabled workgroup. So we would just create a new workgroup and there we set the engine to Apache Spark. And then after we have set this up, we can now use Spark also with this workgroup. So this would have to be set up with another workgroup and we can create up to 1000 workgroups per region. And by default, each account has a primary workgroup. So this is always available. And here the default permissions allow all authenticated users access to this workgroup, and this cannot be deleted. So of course, if we create another one, we can also configure the access to this using IAM just. So this is the workgroup. And now we also want to lastly talk about the performance in Athena, which is also very important. Let's now quickly have a look at how we can set up and configure a workgroup in Athena. So if we just navigate to the service Athena, we can see on the left side navigation. So if we expand this navigation at the left side, so now we are in the query editor, we can see also under administration the work groups. So as we have said, we have our primary work group. This is always available. And here we would just use the Athena engine. And in here we can see some of the configurations, and we have this one as the main one. So when we run a query in the query editor, we can see that we would use in this case the primary work group, but we could also have other work groups that we might also have access to. So if we would want to create another work group, we could set this up again here in the console. So to do this, we could create a new workgroup from here. We could say, for example, this is, let's say, report generation, something like this, or another type of team, maybe a development team. We could specify a name like this. And here we could choose the type of engine. So as we have said, either Athena SQL for the interactive queries, or we can also use Apache Spark for using the serverless Spark engine also. This is also possible. In our case, we just leave it at the Athena SQL default. And here we could do some additional configurations in regards to the authentication. We will also leave that here at the default. We could also, of course, configure our own query result location. So here we would have to specify a given bucket, for example. And also we can have usage control in place. So here we could set, for example, data limits. Or we could also say that we want to set some usage alerts. So like this, we can just control and track the cost a little bit more isolated for specific teams or specific workloads. And if I, for example, just create this work group like this, I see this has been created very quickly. We can see that in this case, we have also here the metrics. So we can just control and track the cost and the usage a little bit more isolated. But we can also now see how we would use that. So if I go now back to the query editor, I can now use the primary work group, but I can also say, in this case, we should use the report generation work group. So this can be also set up here in this query editor. So this was just a very brief demonstration here in the console. Hope it was helpful and see you in the next lecture.